as soon as I started the class, a couple of my students said that they have solved this problem. I'm quite happy about it. What about others? Did you attempt and solve this problem? Hello? Hello, quickly. Say yes or no. See, only Arun and Aniket said they have solved this problem. What about others? See, 3 days I gave you this problem so that all of you will think and you come out, and I told every student should come out with solution. See, I am not getting very good response from many students, I am telling you. See here, I don't get any response from Anushri, Prabhu, Aditi, okay. Aryan could have done this, but for God, I don't know, for whatever reason he has not attempted this problem. Okay, anyways, I will finally to give you the solution to this problem. So now, as you see students, this 40 kg person will shift here and 60 kg person will shift here. So what happens if they shift? Okay, supposing the center of mass was here, the center of mass was here. If this was the center of mass will not change if this fellow shifts here and this fellow shifts here. Correct? Hello?
Yes, sir.
Yes, sir. Okay, so therefore the center of mass will be there only. But what happens is 60 kg has shifted to the left, so the plank will move to the right by some distance, and 40 kg will shift to the right, so the plank will move back some distance to the left. But the net shift will be towards the right. Correct?
Yes, sir. Yes, sir.
So therefore, I would rather now mark the shift like this. That is, the plank would now, because of these two movements, the net displacement of the plank will be towards the right. Okay, right? Okay. Now what I do is this distance, if I take it as, if I take this net displacement as delta x AC, that is A has shifted to C, C has shifted to A. So this is the net shift. Okay. So with this in mind, if we coin the equation, with this in mind, we coin the equation. What is that coin the equation here? So here, you see the position. See, how will you write the equation for this? If the shift, because XCOM will be same. XCOM will be same. Right? XCOM, that is initially if you have taken XCOM, initially, that is before shifting, if you have taken XCOM, it would have been simply what? MA into XA, that is the position of this, I will say it as XA, and MB into XB plus MC into XC plus MP, mass of the plank, into XU, okay, divided by summation M. Summation M here happens to be 240 kilos. Okay, hello, are you with me? Now, the next thing that happens here is, again, I'm going to write here XCOM. So now that A has shifted to the right and B has shifted to the right, the positions, that is, you see, the positions of this, I have marked it as XA with respect to some reference. Okay, so I have taken this as the reference, X is equal to 0, and I have written XA, XB, XC. So therefore now I can write it as MA into XA plus 4. Correct? Because it has shifted the 4 units the side. Hello? Somebody say yes, no?
Yes, sir.
Plus delta X AC. Agreed? See, this person has shifted this side, and as I told you, the whole plank has shifted to the right. Okay, so I am adding this delta X AX here, plus MB into XB as it is, because this fellow has not moved, but the plank itself has shifted by delta X AC. Okay, so I am adding this to this, and MC, as far as MC is concerned, it has also shifted by delta AC, but it has moved to the left by 4 meters. Hello?
Yes, sir.
And as far as MP is concerned, MP into XP plus delta AC. Okay? And this whole thing is divided by 240. Okay?
Yes, sir.
So, as the things are happening, I'm just writing the equations here, and I'm quickly writing it because we have spent enough time on this. Okay, I don't want to waste much time on this, but this is how you have to build the logic for this. So this happens, and now be quick students. See here, MA into XA, okay, MB into XB, MC into okay, I have not written here XC. You didn't remind me. Okay, sorry. Here XC plus should come. So MC into XC and MP into XP divided by 240, that is this, is equal to XC over. Correct now? Hello?
Yes, sir.
So on the right hand side, I will be left with simply MA into 4 plus delta X AC, okay, plus MB into delta X AC plus MC into delta X AC minus 4, okay, plus MP into delta X AC. I suppose you understood. Hello, divided by 240. Okay, so this whole thing divided by 240. Okay, because the other things, MAXA plus this one and all will cancel with this, right? So the next step, would be what? The next step would be that I have to now do the manipulation here. Now look at the manipulation here. So I can now bring out this delta X AC outside, and remaining things I can keep it as it is. That is now MA into 4. Sorry, MA into 4. MA into 4, right, plus MB into, okay, MB is nothing, so MC into minus 3, okay, I'm writing as it is. Now, plus, you see here, delta X AC, of course, this is divided by 240, yeah? Let me not forget it, sorry. This is MC divided by 240, okay, then plus delta X AC as it is, that is, I am filtering it out. So if you forgot delta X AC, I will left with MA plus MB plus MC plus MP, correct, divided by 240. Hello, are you with me?
Yes, sir.
Okay, this whole thing. Now MA plus MB plus MP is nothing but 240. So these two I am going to cancel.
Yes, sir.
And this whole thing is equal to 0. Correct? This whole thing is equal to 0. That is this 0. So therefore, I just have to multiply this. What is MA? MA is 40. 40 into 4 minus 60 into 4. Right? This is equal to this divided by 240. Okay, what is this? This divided by 240. If you take it out 240 here, so here 40 into 4 is 160, 160, 60 into 240, that becomes minus 80. So minus 80, minus 80, Mr. Murthy be cool, okay, minus 80 by 240 plus delta X AC. This is the moment of the plant. So therefore, this implies delta X AC will be equal to 80 by 240 is 1 by 3 meters to the right. Got it?
Yes, sir. Yes, sir.
So this is how it has to be organized, and you can quickly get this. This is the logic. I wanted everybody to be calm and cool and get this logic. So I was trying to put pressure on all of you. Anyways, I can't say more than this. I hope all of you understood this.
Yes, sir.
Yes. Okay. Right. Okay, we were in the 13th problem yesterday. 13th or 14th? Hello? Hello? Hey, ಏನು active ಇರ್ರಿ? Hey, what are you all doing, man? When I'm saying hello, nobody is responding.
Yes, sir.
What is there after so much time? Your time is getting wasted. Yesterday, did we solve 13 problems?
Yes, sir.
Alright, solve this problem. Again, you see all these problems, just read the NCERT textbook. The basic theory, the theory that is given there, if you have thoroughly understood that, okay, and bit of the illustrated problems that they have given, and the questions to be solved at the end in NCERT book, if you have solved those things, then these problems can simply be solved. That's all. But you have to work on that NCERT with lot of love and enthusiasm. Just, you should be very enthusiastic to learn. If you do that, then these problems can easily be solved.
Option A. Yes, sir. Option A.
Good, very good. Your confidence level is high. Okay, Aniket and Aruna are answering. What about others? Please do it. I'm very happy, huh? How come you quickly solved? Hello? Okay, one of you should be ready to tell how you solved. I want to know how you people have solved. Both of you be ready. I can ask anybody. You should tell me in steps. I'll write it on the board.
Yes, sir.
Arya also did. Okay, Arya, for a change, you tell me correctly in steps. I'll write it on the board. Please start.
Yes, sir.
First,
sir, we'll write the initial kinetic energy, sir.
Initial kinetic. You tell me what to write. Don't say initial kinetic energy. You write initial kinetic energy. So is equal to so and so. That mathematical formula you write. Tell me.
Yes. Initial kinetic energy is half m v1 square.
Okay. I use Ki is equal to half m v1 square. Okay.
Then final kinetic energy will be half m v2 square.
Okay. Final kinetic energy will be half m v2 square. Okay.
The change in the kinetic energy will be the gain in the kinetic energy, sir. So kf minus ki.
Okay, the gain in the kinetic energy will be kf minus k. Okay.
It will be half m v1 square minus v2 square.
Half m into v1 square minus v2 square. Okay.
Sir, now we can write as half m v1 minus v2 into v1 plus v2.
v1 plus v2 into v1 minus v2. Okay.
Now m v1 minus v2 is the impulse. That is the change in momentum.
So I should write what? You tell me.
I. That m v1 minus v2 you write as I.
M of v1 minus v2.
Yes.
Oh, so m is missing here. No. Okay.
You missed the m there.
Okay, I'm adding that m here. So this one you want me to write it as this one you want me to write it as I. Half into v1 plus v2, and this one you want me to write it as I.
Yes.
Okay. So
So the kinetic energy gain will be this one. Here.
but it is half I bar into bracket v1 bar plus v2 bar. You have got it in scalar form.
So we can write from that v2 v1 square minus v2 square, we can expand and write like this.
How? What? You tell me what is the basis on which you have written expanded integration. See, you have got it. You have got it like this, but it's in scalar form, not in the vector form.
Sir, even if you take half of V1 plus V2 into V1 minus V2 as vector, sir.
Wait. You tell me. I'll write. Thamba. There is something that you are missing. I want to teach you. Okay. Tell me exactly what you want to tell. Correctly tell me. I'll write it.
Sir, you consider half V1 plus V2 into V1 minus V2.
That is what you told me, no? Half into
in the vector form.
In the vector form. Wait a minute. In the vector form, you want to write V1 minus V2.
Yes.
You want me to write like this only?
No, sir. On V1 you put a bar and on V2 you put a bar.
Okay.
Then V1 plus V2 in another pattern.
V1 plus V2.
You put bar and post.
Okay.
Sir, now here when we take the dot product of
Wait a minute. Thamba. You are telling me to take what between these two?
Yes, sir, you multiply the vectors.
Multiply the vectors.
Yes.
Multiply.
Yes, sir.
Okay, everybody are listening?
Yes, sir.
Only Aniket is telling yes, sir. So, is he right in telling this? Is Aryan? See, all of you, I am taking so much interest to teach you people. You please respond, learn. Is he right in writing like this? Is he right in writing like this? Anybody tell? Is he right? Aniket, is he correct? Arun? Will you speak or no? Say, is he right or wrong? You just tell me right, wrong. I want to know the response of the students. Come on, speak. Everybody, make your mic on. What Aryan has told, is he right or wrong? Hello, unmute your mic, all of you. Unmute, everyone. Unmute, everyone. Speak. Everybody unmute and speak. Is he right or wrong? Arun, are you there?
Yes, sir.
What is wrong with you now? Yesterday, is he right in writing like that or no?
Which type of product is it?
ಇಷ್ಟೊತ್ತನ ಹೊಯ್ಕೊಳಕತ್ತೆ ಅದಕ್ಕೆ ನಾನೀಗ ನೀನ್ ಇಲ್ಲಿ ಬರ್ದಾನಲ್ಲ ಏನ್ ಬರ್ದಾನ ಅದನ್ನ ಅವನ್ ಏನ್ ಹೇಳ್ಯಾನ ಅದನ್ನ ಬರ್ದಾನಿಲ್ಲ. He has simply told write like this. Is he right?
It should be dot product.
Why they should be dot product?
Sir, when we do the splitting of it, given bar minus V2 bar that is dot product.
That is
because
not.
Actually, it is a scalar quantity. Yes, sir. Dot product is scalar. So I did the dot product.
You'll take the dot product.
Yes, we have to take.
So after getting the answer like this, now you are going to write the dot product.
No, sir. We can expand this as like V1 square minus V2 square answer. At the last, the answer will be scalar.
Correct, man. But see, I understood. Your answer is right. I am not disputing. But you see, you have simply you said you are multiplying the two vectors. You cannot multiply the two vectors.
Yes.
So you see, so therefore, if you cannot multiply, but you have multiplied the vector here. Now you are telling we should take dot product. On what basis are you telling we should take dot product?
Since it is a scalar.
No. Okay, yeah, you are getting some quantity as scalar, so you just want to do some dot product and get the scalar. No, basic approach. Okay, see, this is what you see. Answer is right, but you see, in some other sum you could have goofed because this is a fundamental mistake that you have done, and everybody have done probably. Okay, you are not opening it. Okay, now let me do it for you. See, I would rather go like this. The impulse I bar. Okay, so the impulse I bar will simply be what? M into V2 bar minus V1 bar. Correct? By definition?
Yes, sir.
By definition, okay? And the change in the kinetic energy will be half m into v2 square minus v1 square by definition. Hello?
Yes, sir.
Now they are asking us to convert this impulse into kinetic energy. They are asking us to convert this impulse into kinetic energy. Correct? So basically this is the thing that we want. Basically we want this format from this format, isn't it? That is basically what we want. So therefore now to manipulate this, that is, if I want to connect this to this, in order to manipulate it, I would rather go for I bar. Okay, I will simply say I bar into. Now here you see, I bar I am going to take. I now have I bar. Okay, I now have I bar. Now if I take the dot product of I bar with V1 bar plus V2 bar, I am multiplying it. Okay, I am taking the dot product on the left hand side, and whatever I do on the left hand side, I have to do it on the right hand side. So V2 bar minus V1 bar dot V1 bar plus V2 bar. See, I have written the basic equation and now I am manipulating it. Okay, so I manipulate this. Then I have to get the kinetic energy form. So I will divide by 2. I will divide this by 2. See, it is not violating mathematics. That is what you have to ensure. Okay. Now yes, there is a reason why you have multiplied it, why you have taken the dot product. Because you have taken the dot product in order to get this and in accordance with the mathematics. Okay. And of course, this right hand side is nothing but you will get delta. So this becomes the answer. Hello?
Yes.
Okay. But there is a mistake in the this one also here. See, they should have included the dot product here.
Yes,
They should have included the dot product here. See, that is something that is nobody has seen that. Okay. In fact, if you just write like this, it is not correct. So I wanted you to go in steps and justify why you are taking the dot product. I have justified it because you need the dot product as a factor to manipulate and arrive at the final answer. That is, you have to relate the impulse to the kinetic energy. Okay, friends? Never multiply two vectors. See, a vector, one vector A bar can be taken as a dot product of another vector, or you can take it as cross product of another vector, or you can multiply a scalar with a vector. Only these three operations are permitted. Okay, you cannot simply write A bar into B bar, or you cannot write A bar into A bar. These two is formula. Got it, friends? Okay. Okay. So shall we proceed?
Sir.
Okay. Students, see, you please give importance. If there is any theory that you want me to teach you at this juncture, you can request. I will definitely try and do that. Okay, that's your job, is to request. What I want to do, I will do. But just do your job. Okay? Then only the nature will help you to gain knowledge. If you don't do your job, nature is not going to come to your rescue. Keep this in mind. Okay. Okay, solve this one. answer to it. I'll give you full 5 to 10 minutes to solve. Write diagrams properly and do it. At each and every step, see whether the laws are satisfied, the concepts are used properly.
Third answer.
What is the answer?
Option B.
Let me wait for somebody else to do. And be prepared to explain the steps. See, Aryan, you know how we told? I went on writing like that, and I'm going to do that. Okay, so please be ready. Arun, if you are solved by one method and if you got that answer, you don't waste time. You try to solve this by another method. Okay?
Okay. Yes, sir.
Good. Aniket, what is your option?
Option B.
Okay, so 2 students have given this option. Right, let me see. Okay, what about others? Right, 2 students are giving the answer. Okay, Arun and Aniket have given same answers. So who would volunteer? I will just write what you tell. I want to see how you have solved. Who will volunteer? Aniket or Arun? So both don't want to volunteer. Hello, I am asking both of you. Don't you have mouth?
Yes, sir.
ಯಾಕೋ ಟೈಮ್ ಯಾಕೆ ನಿಂದು ಟೈಮ್ ಭಾಳ ಅದಾವ ಏನೋ ವೇಸ್ಟ್ ಮಾಡಕ್ಕೆ ಹಾ ಹೇಳ ಅನಿಕೇತ್ ಹೇಳ್ಬಾ ಆರಾಮ್ಸೆ ಹೇಳ ಕರೆಕ್ಟ್ ಟೈಮ್ ನೀ ಹೆಂಗೆ ಹೇಳ್ತೀನಿ ಬರೀತೀನಿ ಹಾ
Sir, first we will consider 2 cases. Sir. First case, you draw mass. Sir.
which mass of what
4m.
so you tell sir represent a sphere of 4m okay
Yes.
4m ha
Second case, sir. You draw a sphere of mass 2m, sir. And velocity is v downwards, sir.
Velocity is downwards. I write downward. You want me to write? Okay. V
and velocity upwards, sir.
I have to first. You want me to draw here 2m or m?
2m.
2m. Okay.
2m.
And then
We'll consider its velocity downwards.
how much velocity?
v.
Okay.
And another mass m, sir, with velocity v upwards.
Okay.
Now we draw another mass m, sir.
Both are got same velocity, sir?
Yes, sir.
Then I have to draw one more mass. Okay.
Yes.
Huh.
This mass should also have velocity upwards, sir.
Very good, man. Excellent. I'm very, very happy. Excellent. Come on, continue.
Now we will write kinetic energy of each of these masses, sir.
Right. Tell me.
So for the 2m mass, sir, it will be half into 2m into b square.
2m into v square.
B square.
Huh.
Now for the other two masses, it will be half into mb square.
Great. Huh.
So the total mechanical energy should be the sum of all these three, which will be 2mb square.
Yes, that is equal to 2. Brilliant. I'm very happy. Aniket, you are really doing fine, huh? See, there's a sea change in you. Huge change in you. I'm very, very happy. Okay. What about Mr. Arun? Have you solved like this only or some other method?
Same system.
Same. So exactly same, huh? You also took the velocity vectors up or down or like this only?
Yes, sir.
You didn't take sideways, eh?
No, sir.
Okay.
Moment and oscillations. No.
You took it like this also and did it, no? Done. Very good. I'm very happy. Brilliant students. Excellent. What about others? Where did you go? Where did you go wrong? If somebody volunteers, I can help you. I can help you to, correct course correction. You can volunteer, sir. I did like this, sir. So and so. I did not get. Anyways, I can give you a piece of advice and make it better for you next time. If you volunteer. Sir, we don't mind not learning, but our ijjat is more important. We will not expose ourselves. ಏನು ಮಾಡಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಇಷ್ಟ ಟೆಂಪೋಲಿ ವರ್ಕ್ ಮಾಡ್ರಿ ಸಾಕ. You will definitely do much better in the days to come. I have really done a lot of research and chosen the problems amongst thousands of problems that are there. I mean thousands of numerical questions that I have got for this class, for this temperament of the students. So that you should learn, at the same time your confidence should start boosting up. I have set the timer here on another computer. I am not putting it here, so I don't want to put pressure on you, but I am keeping time. आराम से draw diagram. Understand the mechanism. आराम से, then you can solve. The characteristic of the spring. You should know the property of the spring. Already we have seen a situation like this earlier. If anybody is through, you are not getting any clue how to do it, you want some hint, I will give you. Okay, it is almost 10 minutes since I gave you to solve this. So now I have to do it. Shall I do it? Hello? Please, now all of you please pay attention. No problem. If you cannot do it, is okay. You are given a sincere try. That is important. The nature wants you to be sincere, honest, and you should do your effort. That's it. The nature will help you. Don't worry. Okay. So here, the first thing that I will do is, well, you have two things resting on horizontal surface, spring stiffness, so and so. I would draw the two masses. So one is A of 3 kg and connected by a spring of, and this one is 2 kg. This is B. I think this is the first diagram everybody would have drawn. Hello?
Yes, sir.
Huh. Okay. Hello, everybody there?
Yes, sir. Yes, sir.
Right. Then what is the next condition? And the spring stiffness they are given is 480 units. Right? Okay. Then a velocity of 2 meters is imparted to A. So a velocity of 2 meters is imparted to A. So now here you understand this situation. This is A, 3 kg, and at one instant of time, a velocity of V is equal to 2 meters per second is imparted to this. Okay. Now try to understand. How did they give this velocity to this here? Right? That is, I mean, imagine you were there and you had to give this at one instant, it gets this velocity. How do you do that?
We give an impulse.
Excellent. So you have all played marbles, you will give an impulse. So you have given an impulse function that has resulted in this. That is, this impulse function has resulted into change in the momentum. What is the change in the momentum? 3V. Delta P is equal to 3V. Correct? Hello?
Yes, please.
Now what happens? See, you have given this at the instant P is equal to 0. You have given this impulse at an instant P is equal to 0. Then what happens?
There is a spring ball.
This is where you see somehow because I told you several times, and you have not put efforts to learn that. You remember in the previous two problems also we said impulse will not travel through the spring. Correct?
Yes, sir.
Isn't it? So therefore, whatever impulse happened, it has happened to this. And this has started moving. This impulse is not transferred to this. Agreed?
Yes, sir.
Yes.
That is the most important consideration. So that means it has not traveled to this. So as a consequence, that means that means this impulse has not traveled to this. So at the same instant, this is at t is equal to 0, this is at rest. And at t is equal to 0 plus I suppose you understand, just after the impulse.
Yes, sir.
This is still continuing to be at rest.
Yes, sir. Yes, sir.
Okay. And now you see there will be elongation of the spring. I mean it begins to elongate after this time. And that means now the force starts traveling to this. The force starts traveling to this. Okay?
Yes, sir.
So then what happens? So this is moving and the spring elongates. So the spring force is in this direction. Correct? So therefore this becomes the spring force. The spring force starts acting in this direction. Correct? For this in this direction, for this in this direction. Now this 3 starts retarding and 2 starts accelerating. Correct?
Yes, sir.
Okay, so at some other instant, you will find that the 3-1 is having some velocity v which is less than 2 meters, and the spring is now compressed. Okay, and this one is having some velocity v1. I can tell you this is having some velocity. And the spring is now compressed. Hello? Compressed or elongated, you are alert. Good. It is elongated. It is elongated. Okay?
Yes.
So that means the forces will be again in this direction for both. Now, so this elongation will continue. This will start retarding and this will start increasing its velocity. This velocity will start decreasing. This velocity will start increasing. Hello?
Yes.
Yes, sir.
So there will be a time where this velocity of the 3 kg or I'll rather use it VA, the velocity of A and the velocity of B will become equal, because this is increasing and this is decreasing.
Yes, sir.
Okay, now you see, at this instant of time, say this will happen at some instant of time, say t1. At this instant, both the velocities are equal. That means whatever is the displacement of this after this, okay, the same displacement this will also happen, because the velocities are same. Hello?
Yes, sir.
If both are moving with same velocity, whatever was the elongation of the spring, that will not change.
Okay. Yes.
Understood the mechanism? See, the elongation of the spring either compresses or expands will depend upon relative motion between A and B. If there is relative
Yes, sir.
motion between A and B, then only there is expansion and contraction. If the relative motion between A and B is 0, then there is neither expansion nor contraction. It will simply be same, and it is on a smooth surface, both start moving together. Hello? Got it?
Yes, sir.
Now I think you can all do this. Can you do it now? Or you want me to complete this problem? If you don't answer, you will say yes or no.
Okay, complete.
You know?
Complete.
Complete.
What?
Okay, complete. See, it is your time, that is why I am telling you. If you say, sir, give me some more time, you want to do, I might give you time. But that is of no thing. So therefore now, you see, this is the point where the elongation of the spring, in this case, is maximum. It is maximum. Okay?
Yes.
So now the second part of the problem. What is the second part of the problem now? So you see, impulse is just a small a force that you are given at some instant of time. Okay, impulse is a force that you are given at some instant of time, and that's it. Okay. Now, what has happened as a consequence of that? One is there is energy buildup in this half k into delta x max, okay, square, okay, and the two masses have got velocities, half into 2 plus 3, correct, 2 plus 3, mass into both of them have got velocities, okay, maximum extension, and both of them have got velocities, and so therefore now whatever impulse you are given, so it has resulted in this situation. Clear?
Yes, sir.
So this is the situation. But now you see, the moment you have given the impulse, at that instant, this had got some kinetic energy, correct? This one had got some kinetic energy, correct?
Yes.
So this total energy must be equal to the kinetic energy of the 3 kg mass. And this was having what? The initial velocity was 2 square. Correct? So this becomes 6 joules. The total energy is 6 joules.
Yes, sir.
But now the question is the maximum extension. So we need to find out this. So, and this is given to us. And we need to find out this. And what we have got now is this one plus this one is equal to 6 joules. So we need to now get this in order to get this delta x. So can you find out B?
Yes.
How?
Sir, we conserve momentum.
Excellent. So what are the initial momentum?
3.
Yes, the initial momentum was 3. 3 into 2.
Yes.
And the final momentum should be
5 into
5 into V. Correct? So therefore, V will be equal to 6 by 5 meters per second. So that's it. You have to substitute it here. So here, you are going to have here the 2 halves are here. I will transfer it there. So therefore, I will be left with k into something. So I will be left with k into the k also value I know. Okay. Anyway, I'll use it later on. Use the value of k later on. So k value I will use later on. So this delta x square will be as it is. So here this will be equal to 6. I have transferred 2 there, that will be 12, and this is 2 plus 3 5. So this will be minus of 5 into v square. V square is 6 by 6 into 6 by 5 into 5. Okay? Hello?
Yes.
So 1 5 1 5 I can jolly well cancel. So I get here 12 minus 36 by 5. Okay. So the next step is delta x square will be equal to 5 to the 60. 60 minus 36. So that should give me 40, 24. 24 by 5. 24 by 5. And this value is what? K? 480. Value of this is 480. Right? So 24 ones are 24 into 20. Hello? And therefore 5 into 20 is 100. So delta x will be 100 meters. So we have this option. 100 meters. Got it, friends?
Yes, sir.
Yes.
Yeah. So you can see that that the basic mechanism what is you have to understand, and see we have solved at least 2 to 3 problems in this phase 1 only, wherein the spring was there, and I have told you explicitly that the impulse will not be transferred through the spring. Okay, and that is, and I gave you an example also, if you remember, of a capacitor. Okay, a capacitor behaves similarly to a spring, where the voltage across the capacitor cannot change instantaneously. Okay, so here you see the impulse cannot travel. Anyways, that's it. Okay, shall we move on to the next problem, students?
Yes, sir.
Yes, sir.
Yes.
Enjoy learning, I'm telling you. Nothing like this in this world. I have got a timer here on my computer screen, so I have set the timer. So I'll give you 10 minutes to solve, and if you don't solve, then I will start solving. But you don't see the timer, you are on schedule. You want a hint? Hello?
Yes, sir.
Okay. Have you done the basic drawing?
Yes, sir.
So the basic drawing means you have done the cannon and this. You have made the drawing of the cannon. Hello?
Yes, sir.
Yes, sir.
Sir, time including shell of mass means 5 plus m, sir. Or 4m plus m.
4m plus m.
4m plus m, sir.
Read it, man. They have so it's explicitly given it. So I hope you have made this drawing. Hello? Hello?
Yes, sir.
Come on now. All of you pay attention here. This basic drawing is made, and they have made it very clear that the ground is smooth, so I am showing the wheels. This mass is 4m, and you have a shell here. You have a shell here whose mass is m. Hello, are you with me?
Yes, sir.
Now, have you made this drawing? If you have made this drawing, you have done the right beginning. Then fires a shell, the barrel with an angle theta with the horizontal angle theta with horizontal at a velocity u relative to cannon. So that means now, as you know, if this is fired, okay,
Yes.
then so this is fired. This will go in the backward direction. Correct?
Yes, sir.
So this I will take. This will go with b in the backward direction, and they have told this is u with respect to b. That means at the time when it leaves, this will go this side, that will go this side. Correct? Whatever they have told, I have written. Hello?
Yes,
Are you with me? But the important thing is you must all know the mechanism. See, this is mechanics. So the shell will go in the in this part. Shell will go in this part, but this will only travel in this direction. Correct?
Yes, sir.
So the first thing that you should do is split this into two components. So this is going to be u cos theta, and this is going to be u sin theta. That's the first thing that you should do. Right? Hello?
Yes, sir.
Then, well, they have told you where it strikes and all. So now you must find out what the velocity of this with respect to ground. U is the
Yes,
velocity with respect to this. You should find the velocity of the mass. You must find the velocity of the mass, okay, with respect to ground. With respect to ground. Understood? So if you know what is the velocity of this with respect to ground, then you can find a trajectory with the projectile motion. Okay?
Yes, sir.
So now the thing is, first and foremost thing, apply the conservation of momentum here. So if you apply the conservation of momentum, then what is it that you are going to get here? M into u cos theta minus v, because this is what the velocity of the shell with respect to cannon. So I am calculating here m minus u cos theta minus v. It's all with the ground level. Okay, and this will be equal to what? 4mv. Right? This minus this is equal to 0 because it's a shell which has exploded. So this will be equal to 0. So therefore I have just taken it on the other side. Right? So I can strike off this and I can pull the v that side. So I will get here 5v will be equal to u cos theta, or I will get here v is equal to u by 5 cos theta. Did you understand these steps?
Yes, sir.
Hello, everybody there?
Yes, sir. Yes, sir.
You got this? You? Okay. Then, the next thing is now, our next job is what? To find the velocity along the ground. What is the velocity along the ground? A velocity along the ground, that is velocity of the mass with respect to ground. So this is what I am going to find. So what is this going to be now here? This is, as I have written here, it is going to be u cos theta, okay, minus v. We just now count u by 5 into cos theta. Okay, so therefore this becomes what? 5 minus 1, 4. 4 by 5 u cos theta. This is what? Velocity of the shell with respect to ground. And this is what? Horizontal component. So I will also give the suffix x. Okay?
Yes, sir.
Yes, sir.
So we know this horizontal component. Now we have to know. So what is the range? Range becomes horizontal component of the velocity into time, isn't it? So horizontal component of the velocity into time. Time taken to come into t. Correct now?
Yes, sir.
Now, as far as the time is concerned, because it is a bit complicated here, we'll find out the time. So time, as you know, that is the projectile will go up and come down. Correct? So what is the formula for the time? T is equal to 2u sin theta by g.
Yes.
Yes, sir.
Isn't it? So 2u sin theta by g. So substitute that here. So therefore you can find the range. So range R will be equal to 4 by 5 into u cos theta into 2u into sin theta by g. So this gives you 4u square, 2 cos theta sin theta, they are given in terms of sin 2 theta, so write it as sin 2 theta, because all options are giving this, and this 5 is there, so get the 5. So 4u square sin 2 theta by 5g, well, this is the option. Okay?
Yes, sir.
Yes, sir.
So now, Aram said, did everybody draw this diagram? This diagram?
Yes, sir.
Neatly like this. Okay, so if you draw it neatly and present it, then that's the first step. Then if you want to find the range, you should know the horizontal velocity of this shell with respect to ground. That is what is to be found out. So we start using the concepts here. So since it's a cannon, the shell has exploded, so the law of conservation of momentum is applied here. And here it is important. This is with respect. So I have written here u and v simultaneously. So therefore it becomes simply u cos theta minus v. So we are able to get v from this. And once we know v, so velocity with respect to ground will be u cos theta minus so and so to get this. And then we need to find the range for which t is so and so. And that's it. You get the answer. Very, very interesting problem. Very nice. And all the fundas, etc. are used here. We have done it skillfully. Any questions here, students? Hello? No questions. Shall we proceed, students?
Yes, sir.
Done. Okay. Now, am I going fast or am I going slow? Give individually each one of your comments. I can do things to make it better.
Correct, please.
Correct speed up. Can I speed up a bit? But I am giving you 10 minutes time to solve. Some of you might say, sir, don't give that much time. But now you see, during the illustration classes, I was not giving so much time. But now here, we need to. Because this is training session, I want you to get trained. Specially spelled. This is also similar to the previous problem, if not exactly equal.
Done.
What is the answer?
Option
You got option E. Everybody aram se do it now. He may be right or wrong. But you have solved it. I hope it is right. And you have solved it.
is.
Yes, Aryan, what is your answer?
E options.
Okay, good. 2 students have solved. That's brilliant. And that too within time. Just one minute you are able to solve. Okay, let me also solve this. You don't know. Okay, I do got the same option.
Yes, sir.
Aryan, how is that you have
Yes, sir.
solved? How is that you have solved?
Same method.
What about Arun and Aniket?
Same.
Ditto same.
Because
You have drawn the diagram like this or something better diagram than this?
was identical.
Identical? Good.
I didn't draw, sir.
You didn't draw.
Yes.
Why?
No, sir. I imagined it, sir. That's
Yeah. So it's good that you have imagined, but my suggestion to you is in the problems that you have done and you have got wrong answer. If I recollect, there was some vector which you forgot, and therefore you got the wrong answer. Things like that can happen. It's good to imagine, and you have imagined, but try to put your imagination in some drawing so that you will not miss out on something. That's always a better way of doing it. Okay, so because wherever you have gone wrong, it's only because you forgot to write that vector and this vector, because in your imagination those vectors did not appear. Okay, so that's the reason. You see, I do remember yesterday, you see that ring and the rod. Okay, so there you see you could not imagine that your imagination said the ring will be there only. Okay, there is no force to act on the right side. You remember yesterday the ring and the string, and only if you had made a drawing of the ring and the mass, and then you left it, you would have seen the horizontal component, and you would have understood that the ring would travel along the rod. Correct? But you had not made the drawing; you had only imagined, and that is why you goofed. And I saw you the other day sitting here. You were not at all doing any drawing. You were simply sitting and imagining. You imagine, get the idea, put that idea on the paper, and then examine it. You will not get negative marks. Okay, so if and you have also told that sir, I got a lot of negative marks, mainly because of this attitude of yours. Okay, Aniket, did you do something similar or something? You also did the same way as Arun did.
I wrote the equation wrong, sir. I didn't write minus v cos theta, so I didn't get the answer.
You didn't get the answer. Okay, then who was the third student who answered? I heard Aryan answering, I heard Arun answering. There was one more student who said he has got the answer. I don't know. Okay, fine. Now, again, Aniket, did you make the drawing here like this?
Yes, sir. Yes, sir.
But in spite of doing the drawing, you did not write the minus sign here, because it's very clear, that v cos theta was in this direction, and obviously this should be in the opposite direction, because it is going to retest the same path. Anyways, be careful and do it better next time. Okay, shall we move on to the next problem, students?
Sir.
Yeah,
Yes.
good. So fundamental question. taking so much time? Is it a numerical problem? Hello, are you all there or sleeping?
Yes, sir.
Yeah, as if you are solving a big numerical problem. This is basically it is testing your conceptual clarity. Inelastic collision. Hello?
Yes, sir.
Huh. So, what is the theory of the collisions? Anybody? What? Now stop thinking. Now answer my question. Supposing I'll tell you to say something about collision. Collision of two particles, rigid bodies. Okay, or otherwise, okay, just two collisions. What have you got to say? Just collisions between two bodies. If I ask you to write few sentences, what are the sentences you are going to write? If you don't want to answer, then it's no use. I'll just tell the answer and keep going. You are not going to be trained. You tell something, I can help you. Somebody make a beginning. Hello. Useless fellows. So you want me to just tell the answer and get going? This is what you want? Because in college they do the same thing. Just give the answer and keep moving. So you want me to do that? And tell something around. Whatever you.
Three types. Elastic, inelastic, completely inelastic.
Elastic. What are it? Elastic, inelastic, completely
Inelastic.
completely inelastic. Okay, fine.
Sir.
Continue.
Elastic collision.
Listen, others can also join. Others can also join. Yes, please continue.
In elastic collision, sir, the momentum is conserved. In inelastic, sir, in general collision, sir, in collision, sir, the energy is conserved already.
Okay, now stop. Aniket, what have you got to say?
Yes, sir. In collisions of the total mechanical energy of the system is conserved.
Aryan,
Yes, sir.
what have you got to say?
In collision, sir, the momentum is conserved.
Momentum is conserved. Further.
Sir, in some types of collisions like inelastic, sir, energy is lost due to deformation or any other form, sir.
Okay.
So, in all the cases, the momentum will be conserved.
So here I have examined three students, Aniket, Arun and Aryan. Only Aryan has come prepared to the class. He has studied and come. Aniket and Arun have not studied at all. Okay, and both of you, I am telling everyone here is sitting in the class. You have studied so much about collision, oblique collision, that, this, and high level IIT advanced problems. This today and whole day you are free. It's not that you have college. Okay, and I started this SOP 3 days ago. So other students who are not bothered to do whatever little work I have told, God save you. Because this ahankar in you, this attitude in you, this arrogance in you. Arrogance means even after me telling you, I get lost. What is that? We know everything. We are very, very intelligent. We know how to solve sums. You give sum, we will solve this one. We know formulas. You will go to dogs. Some little, you should have some manners. When I have told you, go through NCERT book, mark every concept, write it and send it to me. I had some reason for that. So that, okay, sir has told it's a homework, let me do it and send it. If you had done that today, you would have answered. See, basic. In any collision, momentum is conserved. In perfectly elastic collision, both momentum and kinetic energy is conserved. In other inelastic collisions, kinetic energy is not conserved, but momentum is always conserved. This concept I have taught in 9th standard and also repeatedly told. So you see students, if there are students in this class, if you are not doing well, it's only because of your attitude, arrogance. ahankar. So the nature will not support ahankar. It wants humility, humbleness. So the more you are humble, the more knowledge, the better knowledge you will get. This is a testimony in itself. Okay, thank you very much. Tomorrow we'll continue.